This video is on simplifying radical expressions with variables. To simplify a radical expression that contains variables in the radicand, look for perfect squares of the variables and use the fact that the square root of x squared is equal to x. Let's take a look at several examples here. It says simplify each radical expression. The first one is the square root of 81 x squared. Well, that's the same as the square root of 81 times the square root of x squared, and I know that the square root of 81 is 9, and the square root of x squared is x, so that simplifies to 9x. Example number 2 is 2 times the square root of 48 x cubed y to the 5th. So I'm going to simplify each part of that. So I have 2 times, and now the square root of 48 is the same as the square root of 16 times the square root of 3. Square root of x cubed is the square root of x squared times the square root of x, because x squared times x, recall your rules about exponents, if I add the exponents, that gives me x cubed. The square root of y to the 5th is the square root of y squared times square root of y squared times square root of y, that's 2, 4, 5 y's. So that gives me 2 times 4 times the square root of 3 times x times the square root of x times y times y times the square root of y. Now I can multiply and put out front everything that's not in the square root sign. So 2 times 4 is 8, and then I have 1x and 2 y's, that gives me y squared, and then everything underneath the square root goes together, 3xy. Next example is 3x squared y, or the square root of 3x squared y times the square root of 6xy cubed. Probably the easiest way to do this is just to multiply everything underneath. So that gives me 18, x to the 3rd, y to the 4th, adding my exponents. Now let's simplify that as we did up above. The square root of 18 is the square root of 9 times the square root of 2. And remember, I'm looking for perfect square factors. The square root of x cubed is the square root of x squared times the square root of x. And the square root of x to the 4th, y to the 4th is the square root of y squared times the square root of y squared. Square root of 9 is 3. Square root of 2 can't be simplified. Square root of x squared is x. Square root of x can't be simplified. And the square root of y squared is y. Putting together the things that are not under a square root sign, I have 3x y squared, because I have y times y, and then the terms that are still underneath the square root are 2x. So that simplifies to 3x y squared times the square root of 2x. And our fourth example here is the square root of x to the 5th over 27. So I'm going to go ahead and rewrite that as 2, square root of x to the 5th over the square root of 27. And I'll rewrite each of those with their perfect square factors. So that's the square root of x squared, square root of x squared, and the square root of x. So that gives me my 5x's over 27 is the square root of 9 times the square root of 3. So that's going to give me x times the square root of x over 3 times the square root of 3, or x squared square root of x over 3 square root of 3. But that is not simplified because I have a square root of 3 in the denominator, so I need to rationalize that denominator by multiplying by a square root of 3 over square root of 3. And that's going to give me x squared square root of 3x over square root of 3 times square root of 3 is 3. 3 times 3 is 9. So there is my simplified form of the square root of x to the 5th over 27. So here are some practice problems for you to try. I'd like you to stop the video and copy these and try them in your math journal. Okay, let's take a look at these examples here. So it says simplify each radical expression. My first one is the square root of 49y squared. That's equal to the square root of 49 times the square root of y squared. Square root of 49 is 7. Square root of y squared is y. So that simplifies to 7y. Example number 2, 3 times the square root of 24x to the 5th y to the 4th. I'm going to go ahead and rewrite that as with perfect square factors. So 24, square root of 24 is the square root of 4 times the square root of 6. X to the 5th is the square root of x squared times the square root of x squared times the square root of x. And y to the 4th is the square root of y squared times the square root of y squared, running out of room there, and that's equal to 3 times 2. 6 is a 2 and a 6. That can't be simplified any further, so I'm going to leave that as a square root of 6. And then I have 2 x's and a square root of x and 2 y's. And combining all of the terms that are not underneath the square root gives me 6 x squared, y squared, square root of, now combining the ones underneath, 6x. And number 3, we have the square root of 2x cubed y times the square root of 6xy cubed. I'm going to go ahead and combine those into the square root of 12, x to the 4th, y to the 4th. And we'll just go ahead and write each of those as their perfect square factors. So 12 is the square root of 4 times the square root of 3. X to the 4th is the square root of x squared times the square root of x squared. And y to the 4th, square root of y squared times the square root of y squared. So that's going to give me 2 times the square root of 3 times x times x times y, or 2 x squared, y squared, square root of 3. And my last practice problem here is the square root of x to the 8th over 75. So I will rewrite that as the square root of x to the 8th over the square root of 75. And I'm going to move it down here. Square root of x to the 8th is 4 square roots of x squared. If you're getting the hang of this, you don't have to write all of these out. And square root of 75 is the square root of 25 times the square root of 3. So that's going to give me x times x times x times x, which is x to the 4th, over 5. Square root of 25 is 5, square root of 3. But I have to rationalize my denominator. Can't have that square root of 3 on the bottom. So I'll multiply by square root of 3 over square root of 3. And that's going to give me x to the 4th, square root of 3 over square root of 3 times square root of 3 is 3, times 5 is 15. So in this video, we took a look at how to simplify radical expressions that contain variables. Very similar to simplifying other radical expressions, we're looking for perfect square factors underneath the radical sign.